Okay, so good morning to all. Now we are going to start here. Now see here, just I will take the review of whatever point we have studied in that last lecture. Okay, you all are knowing. Okay, so which part we have covered up till now? We have covered the what is meant by the limit. Okay, may I write what is meant by the limit? Then again limit having the two types. Okay, first is the upper limit and second is the lower limit. Then we have seen here the what is meant by the tolerance. Okay, so what is meant by the tolerance? Tolerance is nothing but it is the difference between upper limit minus lower limit. Again, that tolerance having the two types. Okay, first is the bilateral.
Unilateral.
Okay, sorry, bilateral and unilateral. You can take like this. Okay, that unilateral also. Then what is meant by the bilateral? When we are showing the tolerance to that parts on the both the side of basic size. Okay, means we are showing the tolerance on the plus side also. Okay, and minus side also. Okay, then such type of the system or such type of the tolerances are called as the bilateral tolerances. And then what is meant by the unilateral tolerances? When we are showing the tolerance to that component in only one side of basic size, means either we have to show the tolerance on the plus side. Okay, or either we have to show the tolerance on the negative side. Okay, if such type of the arrangement of that tolerances are there, then we can call it is the unilateral tolerances. Okay, so understood? Yes.
Yes, sir.
Yes, then again we have covered here the following points like this. Different types of the sizes are there. Okay, basic size. What is meant by the basic size? Okay, the basic size is nothing but it is the size. Yes, after giving the
Tolerance.
tolerances to that value. Okay, then it will become the basic size. And what is meant by the zero line? Yes, what is meant by the zero line?
It is the graphical representation of basic size.
Okay, it is the graphical representation of the basic size, and your zero line it will show the exact
Basic size.
basic size. Okay, now we have covered here what is meant by the deviation. Then tell me the what is meant by the actual size. Actual size is nothing but the size of part after the production, whatever size is there. Okay, then it is called as the actual size. Then deviation. Okay, then what is meant by the deviation? Deviation is nothing but it is the good. It is the algebraic difference between actual size minus basic size. We'll got the deviation. Again, it having two types. Okay, first is the upper deviation and second is the lower deviation. Then tell me what is meant by the upper deviation. How we have to calculate the upper deviation?
Maximum limit minus basic size.
Okay, means upper limit minus basic size. Okay, basic size, and we can calculate the lower deviation is equal to lower limit minus the basic size. Okay, now see here. Then what is meant by the allowance? Yes, what is meant by the allowance?
Between two mating parts.
Yes, it is the difference between two mating parts. Then it is called as the allowance. Okay, allowance is nothing but it is the difference between two mating parts. Okay, now see here again that allowance having the two types, positive allowance and negative allowance. Okay, when we can call it is the positive and when we can call it is the negative, that point you have to remember. Okay, allowance is nothing but it is the okay, the allowance is nothing but right here. Allowance is nothing but it is the, yes, please continue.
Difference between two mating parts.
Okay, just okay, it is the difference. It is the difference between two mating parts. What are the two mating parts? For example, there will be the shaft and bone. Okay, two mating parts. Difference between two mating parts. Okay, then it having two allowances are there. First is the positive allowance. Okay, positive allowance, and the second it will be the negative allowance. Then what is meant by the positive and negative allowance? If, okay, you have to remember, if the shaft size, if suppose if the shaft size if the shaft size is smaller, if the shaft size is small and hole size is larger. Okay, suppose this is the shaft and suppose this will be the hole. Okay, suppose this will be the hole. Okay, if such type of the arrangement is there, okay, when the shaft size is smaller and hole size is the larger, that time it is called as the positive allowance, and vice versa. When shaft size, when the shaft size is larger, like this. If the shaft size is larger and the hole size, it will be the smaller, like this. Okay, so this is the hole, this is the shaft. Okay, if such type of the arrangement is there, that time it is called as the negative allowance. Here positive allowance. Okay, that point also you have to remember. Then now see here, how to show the graphical representation of unilateral and bilateral tolerances. Okay, that point I will cover here, and then we'll move to the next point. Now see here, that tolerance, it having two types are there. Okay, first is the unilateral. Okay, the unilateral tolerance system is there, and the second is, yes,
Bilateral.
okay, the second is the bilateral. And how we have to show that unilateral tolerance system and bilateral tolerance system on a graphical representation. So I will draw here the graphical representation. Okay, so before that, you should know the concept. Huh? You should know the concept. Tell me when we can call it as a bilateral, when we are showing the tolerances on the both the side, either on the both the sides means plus as well as minus side. Okay, and here we are showing the tolerances on the only one side, either plus side or either negative side. Okay, then I will draw here the graphical representation for that system. Just have to see here. Okay, so just see here. Now see this is your zero line. Okay, this line is indicate this is your zero line. It is correct. Yes, it is the zero line. Just see, it is the zero line. Zero line means this line, it will indicate the basic size, exact basic size we can call it. Okay, Merit? Yes.
Yes.
Okay. Now see here, suppose this is, what is this? What is this? This is indicate the tolerance zone. It is called as the tolerance zone. It is called as the tolerance. Suppose this is the upper limit. Suppose this is the lower. This is the upper side limit. This is the lower side. Like this. This is the only upper side. Then it shows. See, this is the zero line. Okay, above the zero line, there is also one limit. See, this is the upper limit. It is above the zero line. And again, this is the another. I'm going to draw it like this. Okay. Again here. See, this is the tolerance zone. This is the tolerance zone. Then tell me, okay, then tell me, this is the tolerance zone. The tolerance. Then tell me whether what is the system, whether it is unilateral or bilateral. Okay, you have to remember, and above this zero line there will be the plus, and below the zero line there will be the negative. Then tell me what is the type of these tolerances. This is the tolerance zone.
Unilateral.
Okay, why it is called as the unilateral? Again, it is the unilateral. Why it is called as the unilateral? Because both the limit we are showing on the plus side only. Just a second. When we are showing the limits, or we can say the tolerance zone on only one side. Now see, this is the one, this is the first side, we can say this is the second side of your basic size. Okay, why it is called as the basic size? Because we are knowing that your zero line, it will show the exact basic size. Okay, now see here, when we are showing the tolerance zone on only one side of your basic size, then it is called as unilateral. Okay, means whether either we have to show on the plus side or either we have to show on the negative side. Then remaining, please tell me what is the type of this tolerance zone? Yes. What is this tolerance? Yes.
Unilateral.
Yes. Why it is the unilateral? Because it is the unilateral, correct? Okay, it is the unilateral. Why it is the unilateral? Because we are showing only one side. Yes, only one side means we are showing that tolerance on the only negative side. Negative side. Then what is the type of this tolerance? Yes.
Bilateral.
Why it is the bilateral? Why it is the bilateral? Because we are showing this tolerance zone like here. This is the plus area. In the plus area also we are showing, and in negative area also we are showing. Means above the zero line also we are showing, above the basic line also we are showing, and below the basic line also we are showing. Okay, so it is the bilateral. And then what is this? What is this?
Unilateral.
Yes, it is the unilateral. Why? It is again we are showing like this here. Suppose this is their upper limit and this is their lower limit. Okay, both are in positive direction. Okay, like here again for this side also, and it is their lower limit, and it is upper limit. Both limits are in negative sides are there. Here, so this is the upper limit, this is the lower limit, and both the upper they are showing from the positive side and it is the negative side. Here this is the which limit is there, whether it is upper limit or lower limit. Yes, it is the upper limit. And what is the lower limit for this tolerance zone? Yes, what is the lower limit? What will be the lower limit for?
Basic size.
Means it is the zero limit. Means in the lower side they have not showing the lower limit. Okay, it will be the zero. Like this is called as the graphical representation of your unilateral as well as bilateral tolerances. So understood how to show that unilateral bilateral tolerance on the graphically. Okay, so we will move toward the next point, that is the fit. Okay, fit. What is meant by the fit? Okay, now our next point is the fit. Okay. Okay, fits. Okay, what is meant by the fit? Yes, anybody having any idea what is meant by the fit? What will be the definition for that fit? Yes. What is meant by the fit? Yes. Yes. See here, I will write here. The fit is nothing but it will indicate the fit is nothing but it will indicate the tightness and looseness. It will indicate the tightness and looseness of two mating parts. Okay, just have to remember that fit it will indicate indicate the 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 tightness, or it will indicate the looseness. Okay, tightness or looseness of mating parts. Mating is, what is meant by mating? Mating parts. Okay, mating parts. Okay, for example, just tell me. Okay, just I will take the example here. Suppose this is the hole. Okay, so this is the pen I have taken the for the example purpose. Now, say this is the hole, and suppose this will be the shaft. When I have inserted that shaft into this hole, okay, now it is that shaft, it is easily inserted into this hole. Okay, easily inserted into this means that fit is nothing but it will show whether when that two part we have to assemble. Okay, during that assembly, whether that two parts are fitting tightly or it is fitting loosely, that information we have got from this fit concept. Fit is nothing but it is a simple between, the fit is nothing but it is the tightness and looseness of two mating parts. It is called as the fit. Okay, so understood. Fit is nothing but it is the tightness and looseness between two mating parts. See, these are the two, mating parts are there. Okay, and whether it is loose or tight, yes, whether it is loose or tight,
Loose.
it is the loose. Okay, now say again. Okay, now see here, this is the tight or loose, it is again loose. Okay, means that fit it will indicate to us whether that two mating parts are tight or loose. Okay, that information it will got from that the fit concept. Then what is the need of that fit? Okay, why we are providing the fits? Okay, why we are providing the fits? Okay, now see a need of the fit. Need of fits. Okay, so why we are, suppose we are not giving the fit. Okay, or suppose we are not deciding the unit fit and suppose we are manufacturing the component, then what will happen? Yes, what will happen? Okay, suppose this is the shaft is there. Okay, just this is the shaft is there, and suppose this will be the hole in there. Okay, this is the hole in there. Okay, right now suppose this is the hole, this is the shaft, and suppose we have to fit that shaft into this hole. Okay, means suppose we have manufactured this shaft, again we have manufactured this one, and we have not decided the fit, then what will happen? It will directly make effect on the their assembly, na? Yes or no? If we have not decided the fit, मला हे टाइट पाहिजे का लूज पाहिजे हे मी काहीच डिसाइड केलेलं नाही, डायरेक्ट कंपोनंट मॅन्युफॅक्चरिंग केलं, तर काय होईल? What will happen? It will directly make effect on your assembly. Okay, if we have not decided the fit before the manufacturing or before the production, then it will directly make effect. It will directly make effect on two mating parts, or we can call during the assembly. Okay, then if this is the first, so that overcome this effect, we have to select the fits before the production. Okay, now see here, what is the second need? Why we should know about the fit? Okay, why we should know about the fit? Second is, okay, again that fit it will make effect, again that fit it will make effect on the function of parts. Function of the parts. Okay, that fit also make effect. Okay, and see the effect on their function. For example, suppose, see this is the one part is there. Okay, and suppose this is the repeal. Okay, and that repeal we have to insert it in this gap. Okay, this gap. Okay, this gap. If there is no proper fit is there, no proper fit is there, okay, जर याच्यामध्ये proper fit नसेल तर काय होईल? हे repeal काय होईल? रायटिंग करताना प्रॉब्लेम. म्हणजे काय होईल that feet it also make affect on the function of that part. जर फिटच प्रॉपर नसेल तर पार्टच्या फंक्शन मध्ये प्रॉब्लेम येईल का चालेल व्यवस्थित? यस यस
Problem is
okay, so that we should know about the fit. Okay, then yep, again that fit it will be directly make affect on the cost of the product. Okay, of the cost of the parts means what? जर समजा आपण दोन शाफ्ट आणि होल तयार केले आणि एकमेकाला फिक्सच नाही झाले, अगेन इट विल मेक द अफेक्ट ऑन द कॉस्ट. काय होते? रिजेक्ट होईल ना. रिजेक्ट झाल्यानंतर काय होईल? इट विल मेक डायरेक्टली अफेक्ट ऑन द कॉस्ट मनी लाईक. ओके, फॉर दिस पर्पज okay, for this purpose we should know about the fits. Okay, for this purpose the fits are required. Okay, so understood? The fit is nothing but it will indicate the tightness and looseness of two mating parts. म्हणजे दोन जर पार्ट आपण एकमेकांमध्ये मिक्स असेंबल केले तर ते दोन पार्ट एकामध्ये किती फिट आहेत, ते टाइट आहेत, लूज आहेत, का इंटरमिडिएट आहेत. ओके, ह्या स्टेजला काय म्हणायचं? फिट. ओके, सो अंडरस्टूड? येस.
yes, sir.
Okay, now see here. Again, that fit having three types are there. Okay, now see here, the types of fits. Types of fits. Okay, I'll write here. Types of fits. Okay, generally, okay, that fits are classified into three types. Okay, that fits are classified into the three types. Okay, the first type of that fit it will be the clearance fit. Clearance fit. Okay, what is the first type of that fit? It is the clearance. Okay, clearance fit. Then the second types of that fit it will be the interference fit. Interference fit. Please write down that. Then third types of that fit it will be the transition fit. Okay, transition fit. Transition. Okay, these are the three types of the fit. First is the clearance fit, interference fit, and the transition fit. Okay, so understood? These are the three basic types of the fits. Now we will discuss here one by one. What is meant by the clearance, then what is meant by the interference, and what is meant by the transition fit. Okay, so understood? These are the basic types. Okay, now see here. Okay, so simple concept I will write here. Just a simple. How to remember or what is meant by that clearance fit? Simple. That clearance fit is nothing but, okay, here in that clearance fit, okay, suppose just I will write down here. Just you have to remember in that clearance fit when suppose we are having one shaft. Okay, suppose we are having one shaft. Suppose this is the shaft. Okay, suppose this is the shaft. It is visible to all? Yes. Okay, and suppose this is the pulley. Okay, so this is the pulley. This is the pulleys. So this is the pulley. So I will prepare here small definition or very simple definition. So this is the shaft, this is the hole. Now sir, what is meant by the clearance? Can you explain here? Just observing the figure. And suppose we have to make assembly of that shaft and hole. Means we have to insert that shaft into the hole. Then which type of the fit it will be there? There will be the clearance fit. And can anyone please tell me what will be the definition for that clearance fit? Yes. 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 See here, this is the size of shaft, and this is the size of your. This is the size of hole, and this is the size of your shaft. Okay, and suppose we have inserted that shaft into this one. Okay, what is this? What is this? Yes, हे काय आहे याला काय म्हणू शकतो आपण? Yes, it is the clearance ना? It is the clearance. Clearance म्हणजे काय in मराठी? Yes, clearance. Yes, see, this is called as the clearance. Means we can easily write here. Okay, in that clearance bit. Okay, in that clearance bit, the size of shaft. Okay, the size of shaft is small, and the size of hole it will be the larger. Okay, when such type of the arrangement is there, if such type of the arrangement is there, then we can call it as the clearance bit. Okay, now see here what is meant by the interference bit. What is meant by the interference bit? Okay, what is meant by the, just you have to remember this is very basic concept. Okay, the interference. Okay, in that interference bit. Okay, in that interference bit, what will be the arrangement? In that interference bit, you have to just observe this figure. In that interference bit, the size of shaft. Okay, the size of shaft, it will be the larger. It will be the larger, and the size of hole, it will be the small. Size of shaft, it will be the small. Okay. Okay, and it is called as the interference bit. Okay, so understood. Clearance bit is nothing but, now tell me whether it is clearance bit or yes, just tell me whether it is clearance bit or interference bit. Yes, just tell me whether you are observing this. It is visible to all. It is the hole. It is the shaft. Just I will insert it. Whether it is clearance bit or interference bit. Yes,
Clearance.
clearance bit is there. Okay, clearance bit. Just see now. That shaft is easily inserted into that hole. Means in between that two parts, there will be small clearance is there. Means when your shaft is small and your hole is larger, okay, such condition is there. It is called as the clearance bit. When your shaft is larger and your hole is small, then it is called as the, sorry, the shaft size is larger and your hole size. Here you have to write down the hole. The hole size should be less. The hole size should be less. Then such condition is called as the interference pit. And then what is meant by the transition pit? In the transition pit, the size of hole and shaft, they are overlapping to each other. Overlapping. Okay, then how it is looking? Just I will prepare on the graphical representation, so you will understand. Then just you have to understood the basic definitions, when we can call the clearance, when we can call the interference, and when we can call the transition. Yes. Yes, anyone please tell me when we can call the clearance bit? What is the condition for the clearance bit? Yes.
Size of shaft is small and size of hole is large.
Then it is called as the clearance bit. Okay. Then what is meant by the interference bit? Remaining student, please. What is meant by the interference bit? Yes.
Size of hole is small and size of shaft is large.
Okay, good. And what is meant by the transition bit? What is meant by the transition bit?
Size of hole and shaft overlap each other.
Okay. Just to say, I will draw here the figures. Okay. Just, okay. Just wait. I will draw the figure here. Okay, with the figure I will explain. Now see here, this is called as the shaft. This is called as the shaft. And what is this? Yes. What is this? What is this? Yes, it is the called as the pole. It is the hole. This hole, whatever red color is there, it is called as the hole. And this is the shaft is there. Okay. Now, please tell me, what is this? Yes. Can anybody explain what is this? Yes. It is called as the this portion. What's that? Actually, I have shown. This is the what is this?
Tolerance.
Yes, it is the tolerance zone for. It is the tolerance zone for whether it is tolerance zone for shaft or hole. This tolerance zone. It is for shaft or hole. Yes.
Shaft.
Shaft.
Okay, it is the shaft. And see here, this is the tolerance zone for the pole here. Okay, so I will draw here. So this will be the tolerance zone for the pole. This is the tolerance zone for the hole. Okay, then tell me, please tell me. Okay, for your understanding, I'm going to write here. See, this is the tolerance zone. This is the tolerance zone for shaft. This is the tolerance zone for shaft. And see here, this is the tolerance zone for the. This is the tolerance zone for the. Yes.
Hole.
Tolerance zone for the hole. Okay, now see here. What is this? See, this is called as the upper limit. This is called as the upper limit, and this is called as the lower limit. Again, it is the upper limit for hole, it is the lower limit for the hole. Okay, now see here how we can prepare the definition here. Okay, what is our definition? Yes, and what is this? This is called as the clearance. See, this is the clearance. Okay, this is the clearance between that hole and shaft. It is visible to all. So this is called as the clearance. So this is the clearance. So that it is, we are going to call here clearance. So this is the clearance. Okay, so for the it is called as the clearance. It is called as the clearance. Okay, so what will be the definition for the clearance fit? Yes, what will be the definition for the clearance fit? It's just here. Okay, here in that clearance fit, the tolerance zone, just tell me, in that clearance fit, the tolerance zone of hole is below to the tolerance zone of shaft or above. या क्लिअरन्स फिट मध्ये होलचा टॉलरन्स झोन हा शाफ्टच्या टॉलरन्स झोन पेक्षा वरती आहे का खालती आहे? सिंपल
वरती.
मीन्स कसं इथे लिहू शकतो आपण? हियर इन दॅट क्लिअरन्स फिट, हियर द टॉलरन्स झोन ऑफ द टॉलरन्स झोन of the hole, the tolerance zone of the hole is yes, the tolerance zone of hole. See, this is the tolerance zone for the hole. Okay, see, this is the tolerance zone. This is the tolerance. Okay, this is the tolerance zone for the hole. Okay, here the tolerance zone of hole is above. Okay, above. Yes,
The tolerance zone of
above
shaft.
to the tolerance zone of shaft. Okay. Shaft. Okay, this condition is called as the clearance fit. It is called as the clearance fit. Clearance fit समजलंय का आता? Yes, understood what is meant by the clearance fit? Yes, clearance
Yes,
fit
sir.
is nothing but okay, when the tolerance zone Just see the observe this figure. Okay, the tolerance zone of hole. Okay, so this is the tolerance zone of the hole is above to the tolerance zone of shaft. Okay, okay, such condition is called as the clearance speed. Okay, for your better understanding, also you can remember in the clearance speed there is the size of shaft, it will be less, and the size of hole it will be the bigger. And when there is the some clearance is there, then it is called as the, or there is some gap during the meeting, then it is called as the tolerance. Yes, yes, understood. Yes,
Yes, sir.
okay, it is called as the clearance fit. Okay, then tell me during that clearance fit, okay, during that clearance fit, it will create the allowance, whether it is create the allowance. Yes,
Yes, sir.
which type of allowance is there? This is called as the clearance or allowance, we can say. This is the allowance also, na?
Positive allowance.
Positive allowance. Why it is positive allowance? Why it is called as the positive allowance?
Because shaft size is smaller than hole size.
Okay, so understood what is meant by the clearance speed. Clearance speed is nothing but you have to remember how we have to remember in that clearance speed. Okay, the tolerance zone of hole, it will be above to the tolerance zone of the shaft. Such condition is called as the clearance speed. Then how we have to show graphically? Okay, suppose this is the tolerance zone for the shaft, and if suppose this is the tolerance zone for the hole, it is clearance fit. Yes, just this is the tolerance zone. Okay, this is the tolerance zone. I'm going to draw here. This is the tolerance zone. Okay, this is the tolerance zone for the shaft, and this is the tolerance zone for the hole. Then tell me, this presentation is correct for the clearance bit? Yes, that
No, sir.
why it is no? Yes, how we have to show that? We have to show that like this. See here. See here. We have seen here in that clearance bit, the tolerance zone of hole, it should be above. It should be above, and the tolerance zone of shaft, it should be below. Just see now. Just from this figure, I'm going to draw here from this figure directly. First of all, I will draw here the tolerance zone for the hole. See, this is the tolerance zone for the hole, and see, this is the tolerance zone for the shaft. Okay. This is the graphical representation for the clearance fit. Okay, so this is the tolerance for the hole. See. Okay, now see here, here also you can easily understood. The tolerance zone of the hole is above, and the tolerance zone of shaft is below to that hole. Now see, this is called as the clearance fit. Okay, so understood? Yes.
Yes, sir.
Okay, so can you tell me the any example of the clearance fit? Yes, anybody? When you have seen that clearance fit? Where we have seen the clearance fit? In example, in practical example. Yes. Yes. Here we have seen such type of the fit. Yes. Yes, please. Anybody? No, not me. Where such type of the fit we have found. Yes, in practical daily routine. What are they? Yes. त्या दरवाजाची कडी पाहिली का? कडी आपण म्हणतो, काय म्हणू शकतो त्याला? बंद करताना कडी, कडीच म्हणतो ना?
Yes,
Yes.
sir.
It is whether it is the clearance fit or interference fit. Yes,
Clearance.
it is the clearance fit. Okay. Now see here. Whether you have understood what is meant by the clearance rate? Yes.
Yes, sir.
Okay. So can I move toward the next point?
Yes, sir.
Okay. Now the next bit is the interference bit. Okay. The next bit is the interference bit. Next is the interference bit. Okay. Interference bit. Just similar diagram we have to show here. Simple diagram. Actually, this line should be dotted. This line should be dotted. But just say this is the pole. Okay, so correct. It is the pole now. Yes, it is called as the pole. Okay, now first I will draw here the shaft. Okay. This is the shaft. Okay, you have to imagine this will be the shaft. See, this is the shaft, and this will be the pole. Sorry, it is the pole now. Yes, it is the pole. Okay, then tell me, please, first, what is this? What is this? This I'm going to draw here the hatching. What is this?
Tolerance zone of hole.
Tolerance zone for hole.
Tolerance zone for the hole. And what is this? It is the yes.
Tolerance zone for shaft.
Okay, it is the tolerance zone for the shaft. Tolerance zone for the shaft. Okay, now see. Okay, see, this is the, we can say this is the upper limit for the hole. Okay, this is the upper limit for the hole. Again, this is the lower limit for the hole. Again, see, for the shaft, it is upper limit. It is correct, and it is the lower limit for the shaft. Okay, now see here, and when such type of the arrangement is there, when such type of the arrangement is there, it is called as the interference field. Then tell me how to write the definition here. Yes, how to write the definition here. In this here, please faster. Here in this interference field, yes, yes, yes.
The
Tolerance.
tolerance zone of shaft is above.
The tolerance zone, the tolerance zone of shaft, the tolerance zone of shaft is
Is above to the tolerance zone of hole.
here, just here. The tolerance zone of shaft is above to the tolerance zone of hole, or we can write here the tolerance zone of, in this manner also we can write down here, because in that last definition we have taken like this now. Okay. In that last definition, how we have prepared the tolerance zone of the hole is above the tolerance zone of the shaft. Here in similar manner also we have to prepare. Yes, the tolerance zone of hole. Okay, the tolerance, yes, the tolerance zone of hole. Okay, the tolerance zone of hole is, so this is the tolerance zone. So this is the tolerance zone of the, so this is the tolerance zone of the hole is below the
Tolerance zone of shaft.
below the tolerance zone of the shaft. Okay, this condition is called as the interference fit. Interference fit. Okay, such condition is called as the interference fit. Okay, so understood. And what is the example for this? What is the example for this? The example for the interference fit is the footstep bearing. Okay, the footstep bearing. You are knowing the footstep bearing? Yes. Okay. Now see here, you have to imagine. Okay, how it will be inserted. Okay, see, this is the interference fit. Now, it is the interference fit means simple. The hole size is the smaller and the shaft size is the bigger. The shaft size it will be the bigger and hole size it will be the smaller. Then how it will be inserted into that hole? Okay, you have to remember to insert it or to achieve this interference fit, it is required to make the force on this shaft. Okay, force is required. Okay, means we have to, okay, means suppose we have to insert that shaft. Suppose this is the shaft and the size of shaft is the bigger and the size of hole is the smaller. During that, we have to put that shaft on this hole and we have to apply the force. Okay, we have to apply the force to that shaft and in this manner we have to insert. Okay, means also you can make the hammering. Okay, you have to take the hammer and you have to do the hammering on that shaft. Okay, then it will be fit. Okay, or आणखीन तिसरी पद्धत कशी असू शकते टू अचीव दॅट इंटरफरन्स फिट. सपोज यू हॅव टू हिट दिस होल, म्हणजे हे होल काय करायचं पूर्णपणे हिट करायचं. ओके, हिट केल्यामुळे काय होईल ते एक्सपांड होईल ना. आणि देन वी हॅव टू इन्सर्ट द शाफ्ट बाय युजिंग द फोर्स. Okay, means here to achieve the interference fit, you have to remember we have to require the large amount of the force or hammering is required to achieve that interference fit, because in that interference fit the size of shaft is larger than the size of the hole. Okay, so understood. And the practical example of that interference fit is the footstep bearing. Okay, yes, understood. Yes,
sir.
Okay, right now we have seen here what is meant by the fit. Then types of the fit. Fit is nothing but it will indicate the tightness and the looseness between two mating parts. Again, that fit having three types are there. First is the, yes, first is the clearance fit. Then one point is limited. Then how to show that interference fit in the graphical representation? Okay, how to show that? Yes. Say this is the tolerance zone for the, yes. Okay, then tell me. A tolerance zone कशाचा असेल? Yes. This is the,
shaft.
yes. This is the tolerance zone for the shaft, and this is the tolerance zone for the, yes.
Hole.
Okay, in this manner we have to show. Here it is not necessary to have attempt to draw this figure and just you have to draw this. Okay, so automatically they will understood here is interference fit is required. Okay, so understood. Anybody having any doubt, any problem? Yes. Okay, thank you.